Hi everyone, it's me Arvind, catching you guys on another Math Tutor Edu's lecture video. Okay, in this lecture video we're going to discuss about the techniques of differentiation based on the first derivative over here. Okay, and most probably this video will be in multiple parts. I'm not sure whether it's going to be a 2-part video or 3-part videos. Okay, but then this will be a multiple parts of videos, guys. Okay, because this technique of differentiation is crucial for the students so that you can able to apply those techniques in solving the differentiation question. Okay, so let's get this started. So from here, so I'm going to teach you some of the very basic technique of differentiation. So given that so let's say for example y is equals to ax to the power of n. Okay, so this is your function. So we have a coefficient of a and the power of n. So when you have this type of function, so when you differentiate this based on the first derivative, so where in this case dy over dx, so from here, so the differentiation of y will be, so this n you will times with a, so from here you get this n a, so the x remains the same, the power n will be minus with 1. Okay, so this is one of the basic technique of differentiation, guys, based on the first derivative. So let me box this. Okay, so let me give you a very basic example, guys. Okay, let's say you have y is equals to x squared. One of the simplest example ever. So when you want to find the dy dx for this, okay, don't worry, so I will teach you how to find the dy dx for this. Okay, to find the dy dx, what you do, 2 you times with the 1. Okay, by the way, the coefficient of x square is 1. Okay, just because there's no number in front doesn't mean that it is 0, guys. Okay, in front here is actually 1. Okay, but usually in the algebra we don't write 1x square 1x, so it is understood that the coefficient is 1. So the 2 you times with 1. So let me show you the proper working. So 2 you times with 1. Okay, the x remains the same, so the power 2 you minus with 1. Okay, so from here when you differentiate this, so you get your dy over dx is equals to 2x. Okay, so let me just copy paste this. And okay, by the way, let me just move this a little bit up. Okay, now it's better. So this one, by the way, I write for your understanding, guys. Okay, but if you notice, as you move along, once you get understand the first derivative, I mean the technique of differentiation very well, this one actually you don't need to write. Okay, the technique of differentiation you can just do in one step. Okay, that's how you should able to perform, guys. Okay, don't worry, we will take a look at more examples. Okay, so the similar example, y is equals to x cubed. Okay, so how are you going to differentiate this? Okay, so please pause the video, take your time and come back for this. Okay, in a count of 5 4 3 2 1. Okay, so we're going to find the dy over dx. So in order to find the dy over dx, so what you're going to do is, so the 3 you're going to times with 1 over here. 3 times with 1. Okay, the x remains the same, so the power 3 you minus with 1. Okay, so from here dy over dx is equals to, oops, so sorry guys, it's hanging, it's 3x squared. Okay, let me just underline the answer. Alright, so let me just show you one more example. Okay, let's say for example y is equals to x to the power of 5. Okay, so in order to find the dy over dx, so it will be, okay, 5 you times with the coefficient of 1 in front. Okay, 5 you times with 1. Okay, the x remains the same. Okay, the power 5 you minus with 1. Okay, the power 5 you minus with 1. Okay, so from here you get your dy over dx is equals to 5x to the power of 4. Okay, so take it slow and steady. It's very easy example. As we progress through this technique of differentiation, you will take a look some of the more complex example. Okay, we will increase the difficulty step by step. Okay, so let me just underline the answer. Okay, now let's move on to the another example. And what if you encounter something like this? Okay, let's say you have your function y is equals to x. So what will be the differentiation of y equals to x? Okay, so to calculate the differentiation of y equals to x, so the proper working will be, so dy over dx is equals to, okay, the 1 okay, you times with 1, the constant in front 1, you times with 1. Okay, the x still remains the same. Okay, the power 1 you minus with 1, the power 1 you minus with 1. Okay, as you notice here, you get 1 times 1 is 1. Okay, the x still remains the same, but the power is 0. Okay, 1x to the power of 0. So from here you should understand that x to the power of 0 always equals to 1. Okay, so 1 times with x to the power of 0, so your answer will be equals to 1. Okay, so let me show you another example. So if you still couldn't get this, okay, let me show you another set of example. So let's say y equals to 4x. Okay, let's say if you want to differentiate this, so dy over dx is equals to 1 times with 4. Okay, actually you can just straight away write 4, but for your learning I'm doing this extra steps. Okay, once you get very good in this one, you can just write 1, or even better, I don't want to spoil it too early, but let me just finish this and I will explain it later to you. Okay, so 1 times with 4, okay, and then x to the power of 1 minus 1. Okay, 1 times with 4 you get is 4. Okay, so x to the power of 1 minus with 1 you get is x to the power of 0. So x to the power of 0 is 1. So 4 times with 1 is 4. So one thing you should know from here, so whenever you have a x to the power of 1, whenever the power is 1, when you differentiate it, you will get back a constant. Okay, let's say your y equals to x. So when you differentiate this, you get 1. When y equals to 4x, you get your dy dx is equals to 4. Let's say if you have y equals to 20x. So when you differentiate y equals to 20x, your dy dx will be equals to 20. Okay, so I hope I made this clear. Okay, let me show you another example. So let's say the question gives you y equals to negative 9x, and they ask you to find the dy dx. That means the first derivative of the differentiation or the differentiation. So what will be the dy over dx for this? Okay, the dy over dx for this will be negative 9. Simple as that. Okay, you don't need to perform these long working steps. Okay, this for your understanding. Okay, I'm basically teaching you how to do this. Okay, so y equals to negative 9x. So when you differentiate this, dy over dx, it will be equals to negative 9. Okay, so the power 1 you minus with 1, it will become 0. So negative 9 times with 1, so it is negative 9. So anything when you have power of 1, when you differentiate it, you always get a constant. Okay. So what if you have a function which is a constant itself? Let's say y equals to 5. Okay, what will be the differentiation of this? Okay, so whenever you meet any constant, let's say 5, 50 or 5000, when you differentiate a number or any constant, your differentiation will be always equals to 0. Okay, your dy over dx will be equals to 0. Okay, why is that so? Okay, let me show you the explanation behind this through the working. Okay, so let me show you this through the working. So y equals to 5, so you can write in this way as well, where y equals to 5 x to the power of 0. X to the power of 0 is 1. 5 times 1 is 5. So can you get the relation between this? So when you differentiate this, 0 times with 5, you get is 0. So the 0 power of minus 1, no matter what is the power, when you times with 0, everything becomes 0. Let me show you the proper working, guys. So dy over dx, so 0 times with 5 x to the power of 0 minus 1. So from here you get 0 x to the power of negative 1. So 0 times with x to the power of negative 1, automatically it becomes 0. That's why you have your dy over dx is equals to 0. Okay, so this is the explanation behind this. So let me just write this in a proper way. So from here, y equals to 5x to the power of 0. So your dy dx equals to 0 times with 5 x to the power of 0 minus 1. Technically it becomes 0. Okay, you don't need to show this all working, guys. Okay, whenever you see a constant, you can just write your dy over dx equals to 0. Okay, simple as that. This is the explanation why it becomes 0. Okay. So enough with the explanation. Okay, let me show you one more example. Okay, what if your y is equals to 50? What will be your dy over dx? Okay, your dy over dx will be equals to 0. Okay. Okay, very straightforward. So let us continue. Okay, let's say you have y is equals to negative 3x squared. Okay, so you're going to differentiate this. So how are you going to differentiate this? Okay, so pause this video, take some time and figure out how to solve this. But if you still couldn't, okay, no worries, I'm going to show you the step by step working now. So 2 times with negative 3, so your dy over dx, so it will be negative 6. So the power you minus with 1, so 2 minus 1, so from here you get is 6x. Okay, very straightforward. So let me show you another example. Okay, and this time I'm going to show you in this format, d over dx, okay, in a bracket 10x cubed. So when you differentiate this, okay, you get, okay, 3 times with 10, so from here you get is 30, 3 times with 10, Okay, and then the x, the power, you minus with 1. So 3 times with 10, you get is 30. Okay, x power of 3 minus 1, you get is x square. Okay, so this will be your answer. Okay, so let us move on to another example. So back to this form. So let's say the question give you y is equals to negative 2 x to the power of negative 3. Okay, so how are you going to solve this? Okay, let me teach you. So from here, dy over dx, oops, it's hanging guys, so sorry. So dy over dx will be equals to, so the negative 3 you times with negative 2. So from here, negative 3 times with negative 2. Okay, the x will be power negative 3 minus 1. Okay, so you solve this. So you get your dy over, wait guys, so you get your dy over dx is equals to 6 x to the power of negative 4. So this is your answer. So let me underline this. Okay, so let us take a look at another example. Okay, trust me guys, if you notice something, I'm literally showing you many examples. Okay, I want you to master this. Okay, let's say you have y equals to 1 over 2 x to the power of 8. Okay, so when you differentiate this, so your dy over dx, okay, before this we are only dealing with numbers. Okay, now we are dealing with fractions. Okay, so dy over dx is equals to, so 8 times with 1 over 2, so from here you get is 4. Okay, so from here x to the power of 8 you minus with 1. Okay, if you still don't get this, no problem, let us do this one by one. Okay, let us do this one by one. So half times with 8, okay, x still remains the same, and then 8 the power you minus with 1. Okay, this one is simplify 1, so this one is simplify, get is 4. Okay, so from here you get your dy over dx for x to the power of 7. Okay, please give me some short break. I want to drink a water. Meanwhile, if you want to take break also can. There's nothing wrong. Okay, all right. Unfortunately, it's just a 10-second break, so sorry. Okay, so let us back with more set of examples. Okay, now, okay, we deal with fractions. Okay, next we go for the decimal. So let's say you have y is equals to 0.2 x to the power of 9. Okay, what will be this? What will be the dy over dx? Okay, dy over dx. So 9 times with 0.2, so you get is 1.8. Okay, so 1.8 so x. So the power 9 you minus with 1. So from here you get is x to the power of 8. Okay, so simple as that. Okay, so I'm showing you what are the possibilities that they can ask you, okay, within the techniques of differentiation. Alright, so from here, okay, let's say if the question gives you like y equals to 4x power 5, okay, and then plus with 7x cube, wait, 7x cube plus with 21x, okay, and then you minus with 5. Okay, let's say the question gives you this and then they ask you to find dy dx. So how are you going to find? Okay, so from here let us perform the differentiation. Okay, so the dy dx, it will be equals to, okay, 5 you times it 4, you get 20. Okay, the x, so you write here the power 5 you minus with 1, so you only left with x to the power of 4. So you're done with this, then go for the next one. 3 times with 7, how much you get? 21. Okay, and then you write the x over here, the power 3 you minus with 1, so you only left with 2. Okay, you're done with this, go for the next one. Okay, now you have 21x, the power is only 1, so when you differentiate this, so the 1 you times with 21 and then the power will be minus 1, so the power of 1 will become 0, so technically you just get 21. Okay, here you have a constant. Anything when you differentiate a constant, you'll end up getting 0, so you just neglect this value. Okay, technically you plus with 0, but you don't write plus 0 over here, guys. Okay, so this is your answer, 20x to the power of 4 plus 21x squared plus 21. Okay, alright, so from here let us take a look at a few more examples, okay, which involves the surd, because I know surd, many of you might not be able to understand this, but don't worry, I'm going to teach you regarding this. Okay, so from here y is equals to square root of x. So when they give you this and they ask you to find the dy over dx, so how are we going to do this? Okay, step number 1, so this square root x, first thing first, you convert this into the power form. So in this case your x, you change it from the square root to the power of half. So in this case it will become x to the power of 1 over 2. Okay, now it is easier for us to solve because we can relate this with the formula. Okay, now can we solve? Yes, we can. So let us solve this. So your dy over dx is equals to, okay, the half you times with 1, so from here you get is half. Okay, x to the power of half minus 1. Okay, so you solve this, so you get your dy over dx is equals to half x to the power of negative 1 over 2. Okay, so half x to the power of negative 1 over 2. So whenever you have a negative power, you can actually place this into the denominator of a fraction, guys. Okay, so how are you going to write this? So let me show you. So dy over dx is equals to 1 over 2 x to the power of 1 over 2. Okay, x to the power of 1 over 2 is also known as square root x. So you can write your final answer in this way, where dy over dx is equals to 1 over 2 square root x. Okay, so this is your final answer. Okay, by the way, I'm showing this long steps for your learning purpose, guys. Okay, but then once you already mastered the concept, you can also neglect some of the redundant step. Okay, you only show the important step only. Okay, so let me show you another example. Okay, let's say you have y is equals to 5 root to the power of 5 and then x to the power of 4. So how are you going to solve this? Okay, similar step, you first convert this into the power form. Y x to the power of 1 over 4 x to the power of 4, okay, and then you times with 1 over 5. Okay, so this is the form. Okay, I hope you guys understand this. So from here 4 times with 1 over 5, so from here you get your y is equals to x to the power of 4 over 5. So sorry guys. So let us solve this. So from here, can we perform the differentiation? Yes, we can. So from here, dy dx will be equals to 4 over 5. Because 4 over 5 you times with 1, you get is 4 over 5. Okay, and then the x you just write down, copy down. Okay, and then the power you minus with 1. So 4 over 5 minus with 1. Okay, and then from here, okay, you get dy over dx is equals to 4 over 5 x to the power of negative 1 over 5. Okay. So remember, the negative power you can move their index into the denominator. So from here your dy over dx is equals to 4 over 5 x to the power of 1 over 5. Okay. You can leave your answer in this way, or if you want to write in the root form also can. Okay, 4 over 5 root to the power of 5 x also can. Okay, all right. We still have one more example left. So let's say you have y equals to 1 over x to the power of 4. So how are we going to find the differentiation of y equals to 1 over x to the power of 4? Okay, now you have a fraction and you have a index in the denominator. Okay, first step is, so the x to the power of 4, from the denominator you move to the top, which is numerator. So from here y equals to x to the power of negative 4. Okay, because we want to change the format into the formula that we can apply. Okay, so from here now we can calculate the differentiation dy over dx is equals to negative 4 x to the power of, so negative 4 you times with 1 in the front, the coefficient, you get negative 4. Okay, the power 4 you minus with 1, negative 4 minus 1. Okay, so from here you get your dy over dx is equals to negative 4 x to the power of negative 5. Okay, and this negative index you can move to the denominator. Okay, you can form the own fraction. So from here you can leave your answer in this way, but to be safe side you convert back into the fraction form. Since the question give you in the fraction form, to be safe side you just convert back to the fraction form. Okay, your dy dx will be negative 4 over x to the power of 5. So the x to the power of negative 5, you move it back to the denominator. Okay, so this is your answer. Okay, so we have come to the end of our lecture video today. So I hope you have understand the technique of differentiation and we have discussed so many examples. Okay, so if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not to forget to share these videos to your friends. Thank you everyone for your support, and I'll see you in the next video.